Welcome back. So in the previous tutorial, we went through the convolutional layer and understood some basic concept of that. So let's review that. So we pass our image through our convolutional layer as we discussed before, and the output feature map will be something like this. From 7 by 7 image, we have a feature map 5 by 5. Imagine that we don't have padding, so padding is equal to 0. So we have a 5 by 5 output feature map. So now we want to pass this feature map, generated feature map from convolutional layer, to another important layer that we call it pooling layer. What is pooling and why it's important? Pooling is actually downsampling operation that reduces the spatial dimensionality of this produced feature map. And it helps actually control overfitting, and also it helps very much in decreasing the computational cost by reducing the number of parameters to learn in a network. So therefore, that's why the pooling layer is actually a very crucial and important layer in convolutional neural network. So what we do in the pooling layer, for example, we have a couple of methods of pooling, max pooling, min pooling, and different other poolings. But the most important ones are max pooling and min pooling. And we start from max pooling so we can understand the pooling method better. Imagine that this is our feature map that we generated in previous staging convolutional layer. So we put a 2 by 2 window in on our feature map, for example, like this, and we say that okay, what is the maximum value between these four pixel values? So the maximum value is 4. So we actually put 4 here. The same thing if we imagine, for example, the stride is 2, stride length is 2, we put our window this time here. And what is the maximum value? The maximum value is 2, so we put 2 here. Again, we go to the right part. So between these two values, the maximum value is 3, so we put 3 here. So we don't have any value here, so just ignore that. Here, the maximum value is 3, so we put 3 here. Here, the maximum value is 2, so we put 2 here. Again, 3, we put 3 here, and we continue this process to here, and for the last one, that is 1, and we put 1 here. So this is actually our pooled feature map that is generated for us, pooled feature map that is generated based on our feature map. By this pooled feature map, we not only reduce the dimensionality of this generated feature map in convolutional layer, but also we actually extracted the important features from this feature map by selecting the maximum values and then decrease the size of that as well. So this process is actually called max pooling operation. And for calculating the feature map size, if you want to, for example, you have your feature map and you want to know what will be your feature map size if you do the operation of the max pooling operation, we have another rule of thumb formula that you can actually use that, and it's using the dimension of or the size of our original feature map. That is, for example, here is 5 minus the dimension of the window, the size of the window that you put here. For example, here we used 2 by 2 window. So 5 minus 2, and then we divide that by s, that is the stride size. The stride size, if you remember, was 2 again. So 5 minus 2, that is 3, divided by 2, that is 1.5, plus 1, that will be 2.5. So we round it up to the nearest integer, that is 3. So we will have a 3 by 3 pooled feature map. So we can use this feature map size formula as well in future. So this was the max pool operation. For the mean pooling, we can the only difference is actually, so the process is the exact same thing. The only difference is when we started to put our window on our feature map and start selecting the numbers, instead of, for example, saying that what is the maximum value between these four values, that is 4, we say that, okay, we get the average of this value. For example, 4 plus 3 plus 1, that is 8, and divided by 4 numbers. So 8 divided by 4, so we put 2 here. So instead of getting the maximum value, we get the average value and put it in our pooled feature map. That's mean pooling. But in this course, I usually use the max pooling method, but feel free to use mean pooling as well as exercise. Before we close this pooling part, just for your information to give you some insights about how much pooling is essential and important. Imagine that I showed you this image before. So this image, if we check the properties of this image, the width of this image is about 2,884 pixels, while the height of it is 3,605 pixels. This is a colored image, so we have 3 channels. So the final tensor that will be given to, for example, our convolutional neural network at the end will be this dimension. So we have 3,605 by 2,884 by 3. So this is just one tensor. Imagine that you have thousands of this tensor, for training your model. So you can imagine that how huge will be that input data for your model, and it takes forever in order to train your model. So that's why the pooling method, the max pooling operation, is actually a very essential and important operation in our convolutional neural network and before giving the input data to our network. So that was it. In the next tutorial, we'll learn about another important layer of convolutional neural network, and that's flattening. Until then, keep exercising.